Hi everyone, today we're going to continue doing scatter plots. Our objective today is to write the equation for the line of best fit and use the equation to make predictions. So we want to say which of these scatter plots most likely has a line of best fit represented by y equals 3x plus 1. Well, the first thing I'm going to notice is that this scatter plot B and D both have a negative slope. They both go downward. So this is a positive slope. So B and D are not likely fits for this. Next, I would draw this line, 3x plus 1, in both A and C and see which one's closer. So for A, there's my y-intercept at 1. And if I drew the slope of 3, the line would look like this. Well, this does not look like the line of best fit that best represents this data. Let's look at C. Again, there's my y-intercept with the slope of 3. That looks better. That shows about half of my points on either side of the line. So C would be the correct answer. Okay, what's the equation for this line of best fit? Well, what would I need to do this? First, I want to find the slope. After I find the slope, I'm going to use point-slope form and change it into slope-intercept form. Okay, so let's look at my slope. First of all, this is a negative slope. You should see that. And if I make my little slope triangle here, I looked at my scale, and my scale is by 1, so that helps. 1, 2, 3, 4, 5, 6. So I went down 6 and right 2. So my slope is negative 6 over 2, or negative 3. Now I could use many points on this line, but these are good ones. I could use either of these. Let's use this one. This one is 6, 4. The ordered pair is 6, 4. Like I said, I could use either of them for my point slope form. And I said 6, 4, and it is not 6, 4, it is 4, 6. I put my y before my x. 4, 6. 6, 4 would be here. That's not on my line. This is 4, 6. So, remembering my point slope form, y minus y1, y1 in this case is going to be 6, equals m. My m is my slope, or negative 3, times x minus my x value, which is 4. I'll use my distributive property, or feed the birds as we like to say. Negative 3 times x is negative 3x. Negative 3 times negative 4 is positive 12. And I still have y minus 6 on this side of my equal sign. It's not quite in slope-intercept form yet. I would like to add 6 to both sides. Now this goes away, and I have y equals negative 3x plus 18. And if you see if my line went way up, you see it's going to be beyond 10 for my y-intercept, so that seems adequate. Let's look at my next example. What's the line of best fit for this? I have 2 points on the line marked. To make it easier, I want to find my slope, put it in point slope form, and then write an equation. So my slope, this one has a positive slope. On my slope triangle here, poorly. I go up 1, 2, 3, 4, 5, 6. and over 1, 2, 3, 4. So my slope is 6 over 4, which is the same as 3 over 2. So my slope is 3 over 2. Now we're going to use point slope form. Let's use this point. It is 8, 6. So I'm going to use 0.86. I'm going to use point slope form, as I said. So y minus my y value, which is 6, equals 3 over 2 times x minus my x value, that is 8. I didn't need to use this point. I could use any point along that line. This would have been fine, 6, 3. I also could have used 4, 0. Any of those would be fine. Okay, I need to distribute. So 3 over 2 times x is 3 over 2x. Three over 2 times 8 is negative 8 is negative 12. And I still have y minus 6 on my left side of the equation. My last step would be to add 6 to both sides. This cancels out, and my slope-intercept form is y equals 3 over 2x That's a 3. It's hard to see. And negative 12 plus 6 is negative 6. And again, if you follow this down, you know my y-intercept is going to be below 0. Okay, so what's the equation of this line? Well, first thing I'm going to look at is my y-intercept. And if I look here, it is at 15. But look, they all have 15, so that didn't help me much. So let's find a point on the line that could help me. I could use this one. I could use this one. Both of those are fine. This one's at 220. This one is at 835. I probably could use this one. I probably could use this one, but these are fine. So let's use our slope formula to figure this out. y1, which I'm saying is 35, minus y2, which is 20, over x1, 800, minus x2, which is 200. This is where paying attention to the scales, looking at the values, is important. I couldn't just count the slope because this scale is different than this scale. 35 minus 20 is 15. 800 minus 200 is 600. Can I simplify this? Absolutely. How about we'll do 5 first. 5 works good. If I divide the top by 5, I get 3. If I divide the bottom by 5, I get 120. Can I simplify it more? Yeah, I could have divided both the top and bottom by 15 right off the bat, but sometimes it's nice to break into 2 steps. Divide by 3, I get 1. Divide by 3, I get 40. So my slope is 1 over 40, and it's letter B. If I didn't clear. Okay, Luke, you might recognize him, wants to know if he's improving his skill in the guitar. He created a scatter plot and drew the line of best fit. If you just looked at this, you might think, oh, he's not getting better, but pay attention to what the axes are. This one says number of mistakes, time spent practicing. So the more he practices, the fewer mistakes he makes. So that is an improvement. So first thing I'm going to look at is, can I look at where my y-intercept would be? If I continued this line, it's going to be up here somewhere, but do I know what that is? Well, it's gone by 1, so this is 10, 11, probably going to be below 12. So it's probably, this one looks like a good idea, but I don't want to say that. It could be wrong. It could be this. So let's give it a try. I need to find my slope. Y, I'm going to say 8, y1 minus y2, which is 1.5. I do not like decimals in my fractions, but that's okay. And I have 2 minus 5. Well, 8 minus 1.5 is 6.5. And 2 minus 5 is negative 3. Can I simplify this? Yeah, I might need a calculator for that. 6.5 divided by 3 is 2.17. So it's either going to be this one or this one, which those were the two I already looked at. So that's a good clue. So now I probably need to use my point slope form to figure out my y-intercept. Let's start with, I'm going to use this one because I like whole numbers. So 8 is going to be my y. Y minus 8 equals, use my slope of negative 2.17. I could have kept it as a fraction. 2.17 times x minus 2. When I feed my birds or distribute, I have negative 2.17x and a negative times negative will give me a positive 4.34. I think I know what my right answer is. I still have y minus 8 on this side. It also shows me you can't really trust your graph sometimes. I'm going to add 8 to both sides. And you'll see my y-intercept is going to be 12.34. So my correct answer is going to be A, not C. Even though if I extended this up, I didn't think it would go above this, but it's very possible. It's close. Okay, let's look at this one. It says the scatter plot shows relationship between age and lengths of baby sharks. That seems like a fun one. Usually, the older you get, the bigger you're going to get for a shark. I'm not sure if they have a time where they stop growing in length, whereas humans do. My slope, y minus y. I start with my 40, y1 minus y2 over x1, 6, minus 3. That will equal 10 over 3. What does that mean? It means that every 10 months they grow 3 centimeters? 10 over 3. My y-intercept, I can see right there. My y-intercept looks like it is 20. So my equation would be y equals 10 over 3x plus 20. So the question is, how big would it be at 12 months? Well, my thing doesn't go out that far, so I would have to substitute 12 for x, because my x values are my number of months. So y equals 10 over 3 times 12, because 12 months, plus 20, because that's how long it was when it was born, 20 centimeters. Simplify before you multiply. And I will say that when my shark is 12 months old, it's going to be 40 plus 20 I think I lied up here. I said it should grow 10 centimeters every 3 months. I'm not sure if that's what I said. So that will be 60. My brain thinks I might have said that backwards. Because my y is my length and my x is my months. So he would be 60 centimeters at 10 months. That makes sense. It would be out here somewhere. 12 months. It would be out here somewhere. Okay. Coach creates a scatter plot and finds that the line of best fit is this. And in this equation, x is the number of times a bat, and y is the number of hits. So if a player is at bat 175 times, that would be my x, how many hits should he have? Well, let's think about our possibilities here. First of all, if you're at bat 175 times, are you going to get more than 175 hits? No, that would not make sense. We can cross off C. We know that's not right. Use your logic. See what you know. So my number of hits is equal to 0.32 times my number of bats, which in this case is 175, minus 20.51. Well, again, I need my calculator because I'm not going to multiply 0.32 times 175 in my head, although it is about a third. 17.92, that seems wrong. Is that right? That seems wrong. 0.32 times 175. That's 56. Yeah, I thought I typed something in wrong. 56 minus 20.51. And I knew I typed it in wrong because I would have ended up with a negative number of hits, and a negative number of hits does not make sense. 56 minus 20.51 I get 35.49. 35 hits approximately. I'm going to make my approximately symbol, kind of. 35 hits. See how you can use your scatter plots to make predictions? Well, that's it. Have a great day. Talk to you soon.